A massive, crazy new dataset by Hugging Face for training vision language models. They say that the main issue with training vision language models is lack of data. They collected 24 million samples, which we will talk more about later, and developed a pipeline for cleaning, decontaminating, processing this data, and generating more data. And their trained models on this data perform better than on other datasets for VLMs. A single sample is a self-contained data point formatted as a conversation. So it can have images, list of one or more images, text, it's a list of conversational turns, source where it comes from, and some metadata like quality scores. So maybe even the most important part is these texts, which is a back and forth conversation between the human and the assistant. This is what it could look like. So in the images, there is a single image of a dog catching a frisbee, and then the user, role user content, what is the dog doing in the image, and then the assistant or AI answers. The dog is in midair catching a red frisbee at the park. And we have source and metadata like relevance score and visual dependency score. So they analyzed these things like formatting, relevance, visual dependency, image, question, correspondence. This is for the reason of filtering. You can choose which type of data you want based on the metadata. So you can say, give me only the samples from the science and mathematics categories with a relevance score of 4 and higher. And relevance score is just how well the assistant answered the user's question, how relevant it is to the question, the answer. And it can go from 1 to 5. For example, if the question is to solve this equation step by step, but the model just gives the final answer without solving step by step, maybe the relevance would be 3 out of 5 because it solved it but didn't do it step by step. This is the data collection pipeline. So first, they just download raw data from Kaggle, Hugging Face, Drive, and other datasets. Then they need to clean it up, remove corrupted images, corrupted or bad text, low quality text, and they need to put it into a chat format like image, user, question, assistant, answer. So the model can learn this chat format while training. In the third step, they want to remove duplicate images using these SSCD embeddings. So the way I understand the way embeddings work is you convert image to a vector embedding, and if the images are very similar, then those vector embeddings will be very close to each other. So that's how they remove duplicate images, and also they want to delete all of the images or text or answers that are found in the 66 most common benchmarks. So the LLM doesn't, or VLM doesn't learn on test questions on benchmarks, so it's kind of cheating. And at the end, we have this quality assessment. So they are using other vision language models or LLMs to judge and rate on these different metadata and categories. This figure shows that here on top in the FineVision subset, we have a lot less contamination, which means we have a lot less data from the benchmarks, the data we are testing on, that we don't want that data to be in the training data. We have a lot less of that testing data in the training data here. And for other dataset subsets, we have more of this contamination. Here we see how diverse this dataset is. So on x-axis, the higher number means more different things are contained in the images. So this is the visual diversity. Like we have dogs, cats, animals, cars, cities. So we want to be as high as possible on the x-axis. So it means we have higher diversity. But also, we don't want like diversity in a way where something just is present in a few images. We want everything to be present in a lot of images. So just like x-axis says we have a lot of different types of images, a lot of different categories, objects on the image, y-axis says for each of these types of images, there are a lot of images with that type. it's not like there are just like 2 images of cats and like 2 images of dogs and then 1,000 images of cars. That's not very balanced. Our dataset is high on this axis, which means it is very balanced, or there is a lot of images for every type. So both of these increase diversity, and Hugging Face dataset is here very diverse in this corner. Here, FineVision dataset is compared against other datasets, and it performs best with enough training. And one reason you would get slower increase here is maybe because these datasets are less diverse. Maybe they have more similar images, for example, so they are easier to learn, but the same similarity that makes it faster to learn in the beginning is also the ceiling for all of the possible learning. So the way I understand this is FineWeb learns a bit slower in the beginning because there is a lot more things to learn, a lot more diverse. But because of that also, it can learn a lot more eventually. And this chart shows the performance on the original dataset, so on these 4 different datasets, and compared to the performance when the testing data is removed from the training data. So when the images that we test on are removed from the training data, which they should be. So this is called decontamination. And this shows that there is just a bit of contamination in this FineVision dataset compared to other datasets. And this shows that the high performance on benchmarks doesn't come from contamination on FineVision, because even after decontamination, it's still highest. That's gonna be it for this quick video, just telling you guys if any of you want to train on vision. I'm making you aware of this. So join my school community to become AI researcher. It's free right now, but soon it's gonna get paid. So hurry up, and link below the video. And see you in the next video.